In this chapter, we'll use the dictation recognizer to convert the user's speech to text, and we'll show the dictation recognizer's hypothesized and final results on the communicator. Now, let's go back into Unity and open the microphone manager script. This script currently contains all the code controlling the microphone, but now we want to add some code for a dictation recognizer. Anywhere we want the microphone to record, we also want the dictation recognizer active and listening. There's a few things you need to keep in mind while you're using a dictation recognizer. First, you do have to be connected to Wi-Fi in order for the dictation recognizer to work. Second, it does have some timeouts, and there are two to be aware of. First, if the dictation recognizer starts listening but doesn't hear any audio input for the first 5 seconds, it will time out. Next, if the recognizer has heard some audio and has given a result, but then hears silence for around 20 seconds, it'll also time out. We'll show how to handle these timeouts during the coding exercise. Another thing to keep in mind is that in order to record from the microphone or any of the recognizers, you need the microphone capability set in your Unity project settings. We have this capability preset in the application you downloaded, but make sure you keep that in mind when you create your own app. You'll need to go to the player settings in Unity and check the microphone capability under Publishing Settings. Now let's edit Microphone Manager to add the dictation recognizer. You can do this as a developer coding exercise, but we'll go ahead and copy the code from the Windows Dev Center. Now let's take a look at the Start Recording function. The first thing we do in this function is to shut down the phrase recognition system. This is helpful because it controls every keyword recognizer and grammar recognizer in your application. This prevents you from having to keep track of every recognizer that you create in your application and shut them down one by one. Then we'll go ahead and start the dictation recognizer so it's now listening to the user's voice. We'll go ahead and set some UI text to let them know that they can begin talking, but because the dictation recognizer is connected to the internet, when it first connects, your first result may take a few seconds to come back. We'll set a flag that we've started recording, which helps us with some UI later on in our application. And then we'll also start recording the microphone. This is the code that was used in the last chapter, but is now happening at the same time as the dictation recognizer. In the stop recording function, we check to make sure that the dictation recognizer is currently running, and then we stop it and end the microphone recording session. The first event we hooked up is the dictation hypothesis event. This event fires frequently while the dictation recognizer is hearing audio. It gives you a hypothesis of what the recognizer thinks it's heard so far in order for you to relay that information back to the user as they're speaking. It will update every time the recognizer fires this event. As it hears more audio from the user and recognizes more words, it may go back and change a few of the previously recognized words. So you may want to replace this hypothesis text every time until you get a result event. Next is the dictation result event. This event fires every time the user pauses, such as the natural pauses at the end of each sentence. This is the final version of the recognition the recognizer will give you, so we go ahead and save it off in our text so far string builder to save for later. We'll also update the dictation display in order to show everything that the recognizer has returned as a result so far. You'll also notice that this event gives you a confidence level, which can be rejected, low, medium, or high, based on how confident the recognizer is of the text it gave you. A few things can affect this, like background noise or if the user is mumbling a little bit. Depending on your app and the environment you expect it to be used in, you may want to only use medium or high confidence results, or you may want to take any result you get. Next, we'll look at the dictation complete event. This fires anytime the recognizer stops listening and turns off. This can be because of normal user interaction when they finish their recording session, or it can be a result of the timeouts I mentioned earlier. In our case, we only care if the dictation recognizer stopped listening because of a timeout, so we'll go ahead and check the cause for a timeout exceeded cause. In that case, we'll go ahead and stop the microphone from recording now that dictation is no longer listening, and we'll let the user know that dictation timed out and how they can restart their dictation experience. The last event we'll take a look at is the dictation error event, which can fire if something goes wrong with the recording session. Most frequently, this will happen if you don't have internet access or lose internet access during the dictation session. At the bottom of this script, we've set up a coroutine called Restart Speech System, which will help us start up our keyword recognizers again. When the dictation session is over and we've stopped our dictation recognizer, it may not stop running instantly. So we keep a check in our coroutine, checking to make sure that it's no longer running, and once it is, we'll go ahead and restart that keyword recognizer. This is the keyword recognizer that's listening for that send message command. Now build and deploy as usual, and this time, as you're recording your microphone message, you'll notice that text of the words you're saying will appear on the communicator. This helps show you what the app is understanding you to say as you're speaking. Now that we've reached the end of our awareness, acknowledgement, and understanding journey, I'd like to show you one more recognizer we can use to add a more natural language interaction to your application.